Okay, so we're recording, and this is our official start of Big Data for this semester. So welcome, everybody. Hopefully we'll get to welcome you all face-to-face here in person in not too long. Yeah, and thank you all again for waking up at 8 a.m. to come do Big Data, both today and for the rest of the semester. I think it will be a worthwhile experience for you all. You know, waking up early can be, well, it's difficult for everybody, but especially for students. Today is going to be a little bit more on the boring end of days. We got our big syllabus to cover, and the syllabus for this class is going to be rather different than the syllabuses for other classes that you've maybe taken before. Everything's going to be on GitHub, and so as I'm going through the syllabus today, I'll also be going through some of the basic techniques that we'll be using to use GitHub for this class. So those of you who've taken CS46 with me or another class with me have seen a lot of this sort of material before. It'll be a little bit review. And so some of the GitHub material we'll go through relatively quickly this week, but it's always good to have a refresher on this kind of thing. And so I'm going to go ahead and share my screen, and we'll get started. Actually, maybe before I do that, just if at any point today that you have any questions about anything, you have a number of ways that you can ask them. At any time, you can feel free to just interrupt me and go ahead and ask away. Just unmute yourself and ask. That's totally fine. I also have a sort of dual monitor setup going right now so that I can see the chat menu and the participants menu where you can raise your hand if you want. And I'll be trying to monitor that occasionally so that if you type a question in the chat, I'll be able to get that answered as well. Yeah, any questions before we get started? Okay, so I'm sharing my screen, and there we go. Hopefully you all can see my Firefox window open right now. It's open to our class webpage on GitHub. The email that I sent out to you all earlier, I think it was 2 days ago now, has this link. If you're welcome to pull it up and follow along, or just sort of sit back and relax today. Future classes will be a lot more sort of engaging and interactive, where there'll be sort of like actual programming tasks for you to follow along with me as we're doing things. But today, maybe just sitting back and relaxing is an okay strategy. Yeah, so this is a standard GitHub repository. In a GitHub repository, you always have a README file that contains like the overall picture of what is contained in the repository, and that's what we're going to be taking a look at. That's what's displayed down here. Before we actually get started with the class material, though, since there's still a few more people who I think might be joining in a few minutes, I'd like to start off with just big picture career information that's help warm us up and motivate us for the things that we'll be talking about today. So the first thing is that the past few years, it's been like a really, really great time to be a mid-level or senior level programmer, and a pretty good time to be entry level. Entry level is always hard because just finding your first job is always a pain in the butt, but it's pretty much like as good a time as there's ever been. Data science jobs, generally following those same trends, with the exception that current pay is maybe just slightly less than a standard computer science pay. And we'll see that here in a second. If you've never seen this levels.fyi website before, there's a really good website that you should be just checking occasionally throughout your career to understand what compensation looks like for different sort of computer science jobs. And so let's just take a real quick look at this. So for Google, L3 is the entry level position. So somebody straight out of college would get hired at an L3. And the average salary for an L3 at Google currently is 196,000. So that's again like straight out of college, average starting salary at Google. And this has only been going up over the past few years and going up considerably. These more senior levels, this is being very slow right now. So somebody who's like an L5, that might be somebody who has like a PhD. So somebody is maybe a lot more similar to my level of experience, or somebody who's been at the company or just in the programming world for maybe 5 to 10 years or so now at this point. Facebook, Microsoft, all these other companies, similar compensations for people at similar career stages. In this class, we're going to be talking a lot about sort of really practical things with managing large-scale systems. There's two particular job titles that covers this DevOps job and a distributed systems engineer. So we'll be talking about the details of exactly what those jobs entail throughout this semester. But you can see just like typical salaries for people who focus on those jobs spread out across the entire industry. So this is including, the salaries we were looking at before, Google, Facebook, Microsoft, those are sort of the top end jobs, the most prestigious jobs. This is including like every job in the market right now, and still very good salaries for this job. So this is the DevOps job, and then the distributed systems engineer. If we look more generally at data science positions, you can break it down to specific companies, specific levels of experience. And so somebody who's like 6 years out of college making 250,000, 8 years out of college, 200,000, 3 years out of college at Disney, a little more than 200,000. So lots of people, very little experience, making lots of money. So these salaries, they're all really good, even though employers have been illegally colluding to reduce salaries. This goes to a link on Wikipedia that you can look at if you want, but there's this really famous email from Steve Jobs called the smiley face email. And I'll just scroll down a little bit so that we can see what that email looks like. And so at the time, Steve Jobs and Eric Schmidt, CEOs of Google and Apple, had this agreement with each other that they wouldn't hire each other's employees. Steve Jobs emailed Eric Schmidt saying somebody from Google was trying to poach one of Apple's employees, and Eric, the CEO, just fired him within the hour. And Steve replied with this happy face. That's illegal in the United States, and so both those companies have been fined, and the practice has stopped, and salaries have only been getting better because of that. So that's one of the reasons why right now it's salaries are so good for programmers. But COVID has actually, it's been really hard on a lot of professions, but computer science is not one of them. It's been really good for computer science. There's this phenomenon called the Great Recession, or the Great Resignation, sorry, that's happened recently, where computer programmers have been leaving their current jobs and going to another job, working remotely, getting a 50 to 100% pay raise. So I'll let you, if you're interested in that, how COVID's impacted CS careers, you can take a look at that link. And so CS employees also get really good benefits compared to other employees. This link talks in particular about parental leave benefits. And just scrolling down here, you can see that, let's make this a little bit bigger. So somebody who works at Netflix, they get a full year of paid leave when they have a baby. Even the sort of worst of these companies, you're getting like 2 to 3 months of paid leave when you have a child. And that's very uncommon in the US. Most industries offer 0 paid leave. It's not required at all in the US. But the tech jobs are so competitive right now that they're offering all of these really good benefits. I know a number of you are seniors right now, and so in the job market, this Reddit forum is a pretty good place to look for just like what to expect from all that, how to find good jobs at this point. And one of the main things that's the focus of this class will be building your portfolio, helping you do things that's going to get you these good jobs, that will land you these good salaries and good benefits and all these things. Yeah. So if at any point you have any questions about anything career-wise, you want strategies helping to negotiate salaries or something after you're doing your interviews, feel free to reach out to me and I'll do my best to help you with that. But yeah, I always think it's good to start with that, wake us up with some good general purpose career information before we dive into the actual material for our class. So let's go ahead and do that. So first, for the class, a little bit about me. My name is Mike Isbicki, and I prefer that you all just call me Mike by my first name. That's, I know, a little bit uncomfortable for a number of you that you're used to addressing your professors as professor or doctor. But again, one of the things that I'm trying to do with this class is get you used to the culture of computer science jobs and programming jobs. And in the CS industry, everybody's on a first name basis with everybody else. We don't use titles to distinguish like who's more important or who's more skilled. It's just sort of expected that you have enough programming knowledge and programming background to respect your elders, respect the people who have more experience and more knowledge without using titles. So I want to get you practice with that, and so just address me as Mike. So again, in this class, we'll be using GitHub for all of our in-class communication. One of the things that means is that there's this system called GitHub Issues that we'll be using to post announcements. And currently I have my office hours scheduled posted as a GitHub issue. Anytime you see this sort of notation of a hashtag and a number in a GitHub repository, this is going to be a link to a GitHub issue. And so if we click that, it takes us over here to the office hours issue, where I'll post updates to what my office hours schedule is going to be. Since we're having this sort of weird start to the semester, this is my sort of tentative office hours plan right now. That Fridays before our lab session, I'll be available for an hour on Zoom. And then Monday, Wednesday, immediately after class, I'll also be available on Zoom. But we'll revisit this 2 weeks from now when we're back in person and try to make things a little bit more convenient for everybody. I know that a number of people will have conflicts with this time in particular, so I'll try to replace that with something else. All the lectures, everything about this class is going to be recorded and uploaded to YouTube. So if for whatever reason you can't make a particular class session, then it's totally okay. You'll be able to follow along asynchronously. Any questions about any of that so far?
Does the asynchronous stuff apply for both in-class and Zoom classes?
Yeah, it's a good question. So when we get to in-person, all of the in-person classes will also be recorded on Zoom. And so you'd be able to log in asynchronously and view them. I guess the advantage of the online Zooms is that you'll have the recordings of any questions and things like that come from students, come from people who are not me, whereas those might not make it into the Zoom recording on the in-person. But I'm going to do my best to make sure that these videos are sort of an accessible reference that you can refer back to. Good question. Any other questions so far? Okay. So some quick fun facts about me. I grew up in San Clemente, so it's about an hour south of Claremont on the beach. One of the reasons why I wanted to come here to Claremont McKenna is because it's close to my home, Southern California, close to family. I like the area. But before coming here to CMC to teach, I spent 7 years in the Navy. I was a nuclear submarine officer, and I always like to rub in the face of all of the physics professors here that I have personally converted 10 grams of uranium into pure energy, and none of them have. I also worked, while I was in the Navy, I worked at the National Security Agency, the NSA, and throughout this course, actually, that's going to come up in a handful of situations when we talk about security issues involving big data and how to keep your big data secure from people like the NSA and other hacker groups that want to get your data. And ultimately, I left the Navy as a conscientious objector, which roughly means that I didn't believe that what I was doing in the Navy was making the world a better place, and so I've chosen to do other things since then to make the world a better place. Did my PhD postdoc at UC Riverside, which is pretty close to Claremont McKenna here, maybe like a half hour away. And in between this and coming to CMC, I spent 2 years teaching in the DPRK, which is North Korea. And I was part of an academic exchange between the US and North Koreans, helping ordinary citizens from both of our two countries get to know each other, develop relationships and friendships in a situation that doesn't have all this political baggage of like diplomatic negotiations and things. This is actually something that's also going to come up throughout this course in different ways that we'll see how, well, some of the applications that we'll be talking about are related directly to finding information out about North Korea that's, information is relatively hard to find about North Korea because of how secluded they are. And we'll also talk in various ways in terms of applications about different things that, so like North Koreans have significantly less money than Americans when starting companies, and how that causes them to develop their software a little bit differently, depending on whether you're in this more wealthy regime like the US or the more restricted regime like the North Koreans are. Let's see, the last thing, which is going to turn out to impact our class a little bit, is that my wife is currently pregnant, and the baby is due in mid-February. So that's going to cause us to have to reschedule, shuffle some things around when the baby actually comes. And again, I'll talk about that a little bit later on. So that's about me, but now about the course in particular. So there's 3 sort of core courses of computer science at Claremont McKenna. CS40 and CS46 are the 2 like introductory programming courses that are the prereqs for this course, CS143. And the way I think of CS40 is like just learning to program on a single computer. And then CS46 is learning to use your computer to control one remote server efficiently. But in this class, in this big data class, we're not just going to be controlling one remote server, we're going to be controlling an army of remote server, potentially thousands of remote servers. And the particular techniques that we're going to use, they scale essentially indefinitely, all the way up to Google scale, where they have literally hundreds of millions of computers and data centers all over the world working together. In order to make our techniques scale to that size, basically all you have to do is charge your credit card proportional to the number of computers that you want to have solving your problem, and it will do that. In this class, you won't have to buy any compute resources on the cloud or anything like that. We provide all that for you for free. But if you wanted to scale even further, then yeah, it's just a matter of spending money and you get unlimited scaling. And we'll talk about the techniques in this class about how to make that happen. So that's the high-level overview. Diving a little bit deeper, so we'll start with what is big data? And the answer depends entirely on the person who is talking. So my answer to this is going to be very different than all the other professors at CMC. And in particular, I call all of them muggles because I'm a Harry Potter fan and they think computer science is magic. So they don't know computer science, so I'm calling them muggles. And muggles tend to think that anything smaller than like 1 gigabyte is big data. That if you can't open it in Excel, or Excel becomes slow when you open it, then it's big data to them. But for our purposes, that's just like tiny microscopic data. Like I don't even notice data that size. If you're Facebook, so Facebook considers tens of petabytes to be small data. So a petabyte is 1,000 terabytes. And so this is like maybe 100 hard drives worth of information. And Facebook considers that to be small data. Facebook ingests this amount of data roughly every hour. And so you have to have very different programming techniques to handle this amount of data than this amount of data. And we're going to be talking about the techniques to handle this amount of data in this class. We're also going to be talking about one of these really big problems in industry, and that's that people try to use this, the tools, things that we'll be talking about in this class for Facebook big data on the Muggle big data. So a lot of non-technical managers, especially if you're working at maybe a bank or any of these companies where like tech is not their primary industrial focus, but tech is sort of like a side thing, something that helps whatever their main economic activity is. If you're working in that situation, your manager is very likely not to be a technical person. And so they're likely to think of big data as this 1 gigabyte size data problem. And they'll hear about Facebook using these sorts of techniques and applying the wrong techniques to the wrong problem. In this class, we'll see why that will cause problems, and we'll talk about different strategies for convincing people that whatever the right solution is for the problem, how to use that solution. So again, for us, big data, I guess maybe more concretely, how are we going to solve problems of this size? Again, we'll be managing a cluster of computers to solve a computational problem. So this sort of like army of computers like this to solve a problem. And for our purposes, if it can be solved on a single computer, then it's small data. It's something that you covered in data structures, and we'll review those concepts a little bit, but we're really focusing on this cluster of computers concept. And then in order to talk about this cluster of computers, there's sort of a whole bunch of information from other upper division computer science classes that we'll be talking about. And I think it's all of the interesting and applied parts of an upper division computer science major sort of compressed down into this one class. So concrete data sets that we'll be working with. There's 3 of them here. The first one is all geolocated tweets sent from 2017 to today. So that's about 4 terabytes of data. So this is, it's not quite the tiny microscopic data that muggles think of as big data. This is starting to get into real big data territory where you need to think about how to process this efficiently. But it's not true big data. The true big data will come when we start talking about this Common Crawl data set and this Internet Archive data set, which are essentially archives of the entire internet. Multiple petabytes in size to handle these data sets. And what we're going to do with this data, by the end of this course, you're going to build your own Google search engine. That'll be sort of the final project of this course that all the homework assignments are leading up to. And in order to make your Google search engine, again, you'll be managing a cluster of machines that are working together to do all of these things. So downloading all the data from the internet, again, using these 2 data sources as our as the data that we'll be using. Extracting, how do you extract the key information from the HTML stored in these data sources? And then the real hard part, the big data part, the thing that we'll be focusing on is how do we access that information efficiently? And sort of Google's requirement for an efficient website is that you're able to run queries, access the web page in under 200 milliseconds. Every time you visit a new web page, the server should take 200 milliseconds to process petabytes of data and give you the correct information. So I have over here loaded right now what this final project is going to look like, this search engine. And I've just done a quick search up here on North Korea. And there's a lot of information here. We're not going to, at this point, go into detail about it. You'll have, again, more labs and homework assignments that will make you more familiar with this later. But you can see there's sort of like normal search results down here, like you would expect from a normal Google search. But you can do maybe more interesting things than you can with Google, like sorting by the time that it was published at, or how relevant it is. Google doesn't let you change how you sort things, but you can do that with the search engine that you'll be developing. You can also, with our search engine, do things like count the number of times that that these particular terms have appeared over the years. So here we go, search for Iraq. My computer is slowing down. And you can maybe do interesting things like find out, oh, okay, 2003 is when the US invaded Iraq, and news publications, things on the internet started talking about Iraq a lot more in 2003. And we'll, again, talk about how to interpret all of this and the code that's running this more throughout the course. But this is the big picture idea of what your final project's going to look like. A cool Google-like search engine. Some of the technologies that we'll be using to make this search engine. So the first one that we'll be covering in roughly the first 3 weeks of this course is called Docker containers. And this is the main technology that's used to have your system sort of deployed on thousands of computers at once, to have this army of computers that you control working together to accomplish whatever your task is. Docker is a super widely used thing in industry. And there's this website called stackshare.io that you can visit, and it shows you all the companies that use Docker. And all the famous companies are using Docker under the hood. So Google, Instagram, Facebook, Uber, Netflix, all the major tech companies, and then thousands of companies that you've never heard of, all using Docker. So with the link open up to. Scroll down here, it shows a bunch of the companies that are using Docker. Got almost 8,000 companies listed. And one of the advantages of this class is because this is such a widely used thing in industry, when you're going in on your interviews with companies, whether it's for internships or jobs, you'll be able to actually talk about the tools that company is using. You can go to the Stackshare website, figure out what are the main tools that the company that you're interviewing with is using at that company, and say, oh yeah, I've used Docker before, and or whatever the other tools are that we'll be covering. So again, Docker, roughly the first month, 2 to 3 weeks of this course. The main part of this course is going to be going over databases. And so that's basically everything after Docker is databases. And this is how we'll be actually storing the data efficiently and accessing it. If you've taken CS40 with me, so in the intro programming course, you've seen the SQLite database, and I built some basic Twitter style web pages using SQLite. And this database is designed specifically for applications and the database on the same computer. So very small scale systems. And again, by small scale, I don't mean the Muggle version of small scale, I mean the Facebook version of small scale. So up to a terabyte of data. Our focus is going to be on this Postgres database system. Postgres has the tagline that it's the most advanced open source database system, and is It's sort of the one that all the cool kids are using these days. We'll talk about why that is when we get to that part of the course. But this is what's going to allow us to separate our application and database onto different computers and scale them up to large systems. In 2 weeks from now, sort of when we're doing the transition from talking about Docker to databases, we're going to be going over something called the Instagram tech stack. We'll be seeing actually all of the technologies that Instagram uses under the hood to run all of Instagram. And their main like workhorse that runs Instagram is Postgres. So it's, again, widely used industry tool. Most of our focus in this course is going to be Postgres on a single computer with many computers connecting to Postgres. We'll talk a little bit about scaling Postgres up to, it's called horizontal scaling with multiple instances of Postgres in the same data center using something called Citus. And very theoretically, we'll talk about like scaling systems of like Postgres sort of throughout the world, multiple data centers. But this is really going to be our focus, and these would be, to go in depth, would be more advanced classes. The main language of databases is SQL. One of the prerequisites that that most of you have taken, but not everybody, is some sort of SQL programming background. And we'll talk about exactly what, here in a little bit, what the prerequisites exact knowledge are for that. And yeah, it looks like there's a question. No questions? Okay. But at this point, the main takeaway is that SQL is very different than Python or other imperative languages that you've seen so far. So we're going to be spending quite a bit of time really mastering SQL. You may have heard of things like NoSQL. Not going to be touching on that other than telling you why I think these systems suck and you should never use them. Another thing that we'll be doing with Postgres is full language search, full text search, talk about how to work with not just English, but like Spanish, Korean, Chinese, all sorts of cool languages. And again, Postgres widely used in industry. And again, all these technologies, real emphasis on applications in this class. And so former students, in particular, Biniam here, has used these technologies from this class to start this webpage next storm, which is just a small scale business that he runs to make some extra money. And if after this class you would like to do something like that, I'd be happy to help you get started with that. Any questions about anything so far? Okay. Yeah, so apologize that it's just me talking right now and maybe a little bit more boring of a class, but I promise things will get more interesting as we actually dive into these technologies and start using them. So the next thing, who should take this course? So this course is specifically designed for data science majors and not computer science majors. And about half of you are computer science majors. And I think it's great that you've taken this course, and I think you'll think it's fun. But you should know that it's specifically for the data science majors. And so because of that, if you're not a data science major or for whatever reason haven't taken the prereqs for this class with me, there's probably some things that you'll have to review a little bit extra. And there's also some material in this course that will duplicate material in your other CS courses, especially the databases course. And you should just be aware of that and be okay with that if you want to take this. So specifically about the prereqs for this class, we're going to spend a little bit of time talking about this because the situation here at the Claremont Colleges is just a little bit confusing with all the different intro computer science courses that are offered. And so I want to make sure everybody's clear on exactly what you need to know going forward. So discrete math is a prereq just for like basic probability and counting, graph theory. I don't think anybody's going to have problems with this part. The foundations of data science, all the different versions, is a prereq just for some basic machine learning, knowing like what is a logistic regression or decision tree type model. We're not going to be developing those in particular in this class, but having that application knowledge will be really useful. The main reason though for this class is some basic SQL knowledge, and in particular how to do SQL joins. When we start talking about SQL, we're going to go really fast for what I consider to be basic SQL knowledge, and then we're going to spend a lot of time on really advanced SQL knowledge, how do you make your queries actually run in microsecond time. And so if you don't have that SQL knowledge, expect to spend extra time on those weeks. Another important topic is regular expressions, which I think most computer science people should have from other courses. Data structures, so we'll be talking a lot about big O notation and balanced binary search trees in this class. I think everybody's going to do well with that. CS46 in particular, though, the data structures course I teach covers all of this material right here. So in particular, basic Unix shell commands, advanced Git usage, using the Vim text editor, analyzing multi-gigabyte data sets. So if you didn't take this class with me, there's going to be 2 extra assignments that I'm going to require you to complete in the first 2 weeks of the course. Those of you who did take CS46 with me, you'll have a relatively easy first 2 weeks of the course. That'll be just a review sort of refresher on this material. And then basic things like Markdown, HTML, and how to use different programming libraries are things that I cover specifically in CS40. I think most of the CS majors, though, will do pretty well with all that. But again, the takeaway from this is that I'm expecting Linux terminal, Git, and SQL join familiarity. If you don't have those things in particular, expect to spend a little bit extra time on those weeks, maybe double the amount of work as normal, and I'll have extra assignments that certain people are going to have to complete based on that. Basically, anybody who didn't take CS46 with me will have extra assignments to complete. Any questions about the prerequisites? Yeah. Say, Saleh? Sorry, how do you say your name? I think you're talking right now, but it's very quiet. I can't hear you.
Okay, can you hear me now?
Yes, perfect.
Will there be resources for the parts of the course that we would not be familiar with?
Yeah, great question. The question's about will there be resources available for these parts of the course? And when we get to the, so up here, there's this week 0 folder. This contains an outline of the sort of the review material that we'll be covering this first week and next week. And these links down here go to review material. And then this lab down here has a bunch of links to all the review material. So there's lots of resources for people to catch up on things that maybe you didn't have prior knowledge of, or maybe you do have some knowledge of that and need to review. Lots of resources about that will be available. Good question. Okay, so how does this relate to other CS courses? So again, one of the purposes of this course, of the big data course, is to provide DS majors with an overview of CS concepts, upper division CS concepts in particular, so that you can communicate at your jobs with the computer science majors. And because of that, there's going to be quite a bit of overlap material with sort of standard upper division CS courses. In particular, so CS 105 is called the Computer Systems course. Guess about 10% overlap, basically how different hardware systems work that we'll be using. The operating systems course talks a lot about permissions, things like processes and threads, virtual machines versus containers. We'll be talking about all of this in this course. Networking, you'll have to do a lot of managing a virtual network in this class to make all of the systems in your sort of army of computers correctly be able to talk to each other. So that's where the overlap from networking comes in. Software development, so again, like this Git, we're going to be really pounding hard on Git, you'll be very, very familiar with Git by the end of this course. Things like test-driven development, continuous integration, microservices versus monolithic architectures. You might have heard those terms before. Microservices is sort of like the hot thing right now that all the cool kids are doing. This idea of something called a 12-factor application, which is a particular method of software development. We'll be talking about all of those things and how they relate to big data. But the main overlap, again, is going to be with the databases course, CS 133, talking about SQL, these things called ACID, MVCC, transactions, and indexing techniques. Basically, we're going to be doing all of the practical, apply, useful things from a database course without all of the boring theoretical stuff that nobody actually cares about and nobody actually uses. Most of the stuff actually that we're going to be covering though, because it's so applied and because most computer science professors are not applied at all, very theoretically oriented, it's very possible that all of these sort of overlapping concepts are not going to be covered in your other courses, even though I personally think they should be covered. And so there's this idea that a lot of computer science majors are adopting called like this missing semester of your CS education. It's just a special course that like fills in the gaps, shows how different things connect to each other. And so this course sort of follows along that mold. And so for you computer science majors, even if there is this overlap, I think you'll find it still a useful and worthwhile course to take. There are a number of big data concepts that you may have heard about that we will not be talking about at all in this course. And so in particular, there are these things, Apache Hadoop and Apache Spark. Those are, in my experience, they're popular among people who don't really know much computer science or people who are like actually working at Facebook on not just petabytes of data, but exabytes of data. 1,000 petabytes is an exabyte. And so we're not covering those because they're just not actually useful in practice. And we'll be talking about things that are better, and we'll talk about why the things that we were talking about are better, and how to convince other people to do the things, like how to convince your manager to do the better thing. There's these things called distributed file systems, which are really cool, but they're very like CS intensive concepts. So we're not going to talk about those. We will talk about this thing called S3, which is part of Amazon's web services. And actually all the data sets that we're using, these Common Crawl and Internet Archive data sets, are stored on S3. And so we'll see how to access these large scale data sets and sort of distribute them to your army of computers. There's a lot of important concepts in geo-distributed databases. So like Facebook, Google, they have their databases that are stored sort of like around the world. And it turns out that there are like physical limitations about the speed of light and general relativity that you have to take into account when you're working at that scale. We're not going to get into those sorts of details though. That is really like more on the applied end. Textbook for this course. There is no required textbook. Basically, every textbook that says it's about big data is at least a decade out of date, and I don't like it. So instead, we're going to be using all things that are freely available on the internet, because people who actually work with big data and actually work in computer science, we have this culture of just making our stuff available on the internet for free. And so here's the main links that we'll be using. And again, throughout the course on each of the different like week folders, I'll be giving you the particular links to the particular like chapters or sections of these documentations that will be useful for that week. but so the main takeaway here is that you don't have to spend any money on textbooks. All the useful stuff is available for free. Any questions on any of that, how this course relates to other courses or textbooks? Okay, hopefully everybody is still awake, but if not, now's a good time to wake up, because everybody cares about grades and how your grade will be determined in this class. So I have a list of a bunch of different assignments that we'll have. So there'll be labs some weeks, but not every week. Lab is basically, for this class, just a small homework assignment, like 1 to 5 points. Many of these labs will give you in-class time to complete them, but not all of them. We will have occasional quizzes, especially in the about the first month or so after we come back in person. We'll have these occasional quizzes, and then probably not too many quizzes the last half of the semester. Weekly homeworks, and again, the first 2 homeworks are specifically for students who did not take CS46 with me, so that'll help just make sure that we're all on the same page in week 3 forward. You'll have a midterm and a final. Both will be open notes, and historically, so this is the second time I've taught this class, and last time people found both the midterm and the final to be extremely challenging, and I expect that'll be the case this time as well. The good news is that there's not like memorization that you have to do. You'll be able to have your notes and things available, but they will be hard exams. And then for seniors, since this is a second semester course, your grades are due earlier, so you will not have to complete a final project, but everybody who's not a senior will have to complete a final project. And so in total, there's going to be between 400 and 500 points, depending on which assignments you have to or don't have to complete. And so your exams will be roughly like 30 to 40% of your grade, and homeworks another 30 to 40% of your grade, and then the quizzes maybe like 10% of your grade. Axel?
Yeah, I had a question with regards to 2 things actually. So first, for the first 2 homeworks, they'll be available also for others if you want to just review some basic stuff from CS46.
Yeah, great question. So the homeworks will be available. They just won't be graded for you. So you're encouraged to complete them again, just to make sure that you understand the material. But the grade, won't be included in your grade.
Awesome. And in terms of the non-senior thing, if I personally am a first semester senior right now because of
you are required to complete this project. Yeah.
Okay. Awesome. Just wanted to make sure.
And so anybody who is a senior if you would like to complete this project, I would be happy to grade it for you and review it for you. The sort of standard time frame that people will be completing this project will be after your grades are due. Lastly, there's a handful of extra credit assignments in this class. I'll be posting all of the extra credits as they come up into this GitHub issue right here. And there's currently 2 extra credits. The first one is that if you see a mistake anywhere in this GitHub repository and you submit a pull request that gets incorporated into the repository, you'll get 1 point of extra credit for correcting the mistake. So this is to give you practice on how to go through this process of contributing to open source projects, and it'll just make the course overall better for everybody, getting these mistakes eliminated. The second of these extra credits is that in this class, we're going to be using Linux very heavily. And so if you install Linux on your personal computer, or if you already have Linux installed on your personal computer and you've been using it regularly, then you get an extra point of extra credit. Let's see, Sam, you have your hand raised?
Yeah, quick question on the midterm and the final.
Sure.
Are we going to be taking those synchronously in person, assuming we're all back, or are we going to be taking those remotely?
Yeah, it's a good question. My current plan is that these will be take-home exams, but I'm not, so I'll say like 80% chance it's a take-home exam, 20% chance it's an in-person exam, synchronous.
Gotcha, thanks.
Great questions. Any other questions so far? Question about now or at the end of semester, if you already have Linux installed. And in order to get this extra credit, you'll have to have, say you have to have Linux installed and be using it before spring break. So the earlier, the better. And you just, in order to actually get it, you'll just show me that you have Linux installed on your laptop when we get back in person, and then I'll go into Sakai and give you the extra credit for that. So if you're planning on doing that, I recommend earlier is better, just because you'll be using Linux throughout this course, and so the more exposure you get to that at the beginning, the better, easier the second half of the course will be for you. Great questions. Any other questions so far? Okay, I've been emphasizing this a lot so far, but all of these assignments that we're doing, they're really geared towards like practical things that you can talk about with employers at interviews, put on GitHub into your sort of GitHub resume that you can show future employers. And so I think this course is going to be really good for your CVs and helping you get jobs in the future. But one of the things that this course is not going to focus on is sort of leak code style questions. And there are a lot of companies, especially the like FANG sort of companies, that do focus on leak code interview questions. And the class that you'd want to take to practice that would be the CS148 graph algorithms with Professor Cannon. That class is not regularly offered because there's, last time it was offered, there was less demand for it. But I think that's just because a lot of the data science major students didn't know about it at the time. And so I would encourage you all to tell Professor Cannon that you would like to take that class with her in the future. And I guess this is only for the data science majors. For the computer science majors, your algorithms class is the equivalent of the data science majors graph algorithms class. Late work policy in this class, 20% off for each day late. So it's not a huge penalty, and I think that in general, it's better to submit an assignment late that's correct than an assignment incorrect that is on time. Grade schedule, so normal sort of grade distribution with 2 caveats. And there's 2 special caveat tasks that you'll have to complete in this course. For each of these tasks, if you do not complete it, you will lose a full 10% on your grade. So an A- would go down to a B- if you don't complete it. But I expect both of these tasks to be relatively easy for people, and I think everybody should be able to pass both of these tasks just fine. The first task is this type speed task, which the first lab will go over in detail about what it's requiring you to do, but it'll give you some basic exposure to or practice with terminal commands and help you build up your touch typing speed a little bit. And the second task is a hacker culture task. This one's a little bit, it's an easy task, but maybe explaining it's a little bit complicated. One of the purposes of this course is to expose you all to this idea of hacker culture. And hacker culture is this subculture that enjoys intellectual challenges, creatively overcoming the limitations of software systems, open source, these sorts of things. And so it's not about like breaking into people's computers or things that muggles associate with hacking. And I have a number of different things that you are allowed to pick from here to complete this task. There's a number of videos that you're allowed to watch, or things that you're allowed to read, both fiction and nonfiction for both the videos and the readings. And I'm just asking that you spend about 10 hours doing this throughout the semester. So each one of these tasks is worth 1 point. You have to complete 5 of these tasks and you complete the assignment. Once you've completed all of this, there's this GitHub issue over here that you'll just reply to, telling me which tasks you did and what you liked or didn't like about the videos or readings that you did, and then you'll get full credit for that task. So again, both of these two things, you have the entire semester to work on, and they should be relatively easy to do. But if you don't do them, they'll have a pretty significant impact on your grade. If you have questions about these, then it might not be totally clear exactly what's expected right now, but you can review the instructions, and you have plenty of time to ask questions about them throughout the semester. Any other questions about grades at all in this course? Okay, so the next is the schedule this course for this semester. And the schedule is going to be a little bit sort of complicated. What I have listed here is sort of a tentative schedule of what I consider to be like on track for us this semester. We'll be spending the first 3 weeks building up through this idea of DevOps. And again, DevOps is this, stands for Developer Operations. It's the term for people who are managing these sort of cluster of machines, making sure that programs are working correctly. And when we talk about these Docker containers, starting the containers, starting the virtual machines that you're using, and just making sure that the whole overall system is connected correctly. And then everything else is going to be focused on SQL and databases, and this first portion of SQL up through, almost up through spring break, but not entirely, is going to be focused on just understanding SQL queries, making them correct. And then the last half of this course will be focused on making your SQL queries fast, using these special techniques called indexing and triggers and roll-up tables and probabilistic data structures. So again, we have Monday, Wednesday classes, normal class sessions, but we also have Friday classes. And these Friday meetings are mandatory in the same sense that the Monday, Wednesday meetings are mandatory. That means I'm not taking attendance. You don't lose like points on your grade if you have to miss a class or something. And they'll be recorded just like the Monday, Wednesday ones. So if you have to do it asynchronously for whatever reason, that's totally okay. But it's not, they're going to be like normal normal class sessions. And so the reason we have sort of 3 normal class sessions scheduled a week is because, again, I am going on paternity leave this week. I mentioned this semester. I mentioned earlier that my wife's currently pregnant and the baby is due mid-February. So the actual due date is February 25th. My wife, all of her previous babies have come like 2 to 3 weeks earlier. So probably, I don't know what's the exact date, but sometime like February 10th to February 20th is probably when the baby will come. And when the baby does come, I plan on taking 2 weeks off that I just won't be available at all. And so in order to make up for that missed 2 weeks of class time, we're having these Friday sessions in the other weeks. And that will ensure that we get the same overall amount of class time and are able to cover all of the topics that we're supposed to cover. So the main thing that, the main way that impacts you, the thing that you should be thinking about for this course and planning your time, is that this course is going to be run about 25% faster than a normal course during the times when I'm not on leave. So that'll be like here at the beginning. Right now, starting on Friday, we'll be going really fast through all of this early material, and then and then when we come back after the baby, we'll continue going really fast. That also impacts your schedule for like quizzes, midterms, and finals. That because I don't know exactly when the baby is going to be due, I can't give you an exact day for the different exams in this class at this point. What I can say is that the midterm will be approximately like a week to two before spring breaks, and the final will be approximately on the second to last day of class. But I will adjust these dates so that it is reasonable with however the both the leave period falls and is going to give you enough time to actually prepare for the exams. And I promise that I will do my best to be reasonable with all that, but yeah, I can't give you exact dates. So if, yeah, those are things to keep in mind as you're planning for what the workload for this class is going to be like in comparison to other classes. Any questions about the schedule? And in particular, I know this is sort of like a weird thing right here. Any questions about that and how that'll impact you? So the question is, at what point in the semester we'll be adding the web crawler API? When we talk about this, this DevOps stuff, especially this CRUD apps part, this is going to be putting like, you're basically actually going to be building like a small version of Instagram in this week right here that has a web front end, a database back end, and these Docker containers managing your entire system so that you can just basically type run on AWS or run on Microsoft Azure or run on Google Cloud and deploy your app instantly to any of these different locations. And this is the time when the web development will sort of be coming into that. You're not going to be doing any like super heavy web development. It's basically just copying and pasting web code that other people have. And then when we talk about the database stuff, that'll be sort of sitting as a particular part inside of this CRUD application. So questions about the common crawl in particular and how all those three different data sets. So we have three different data sets that we're working with in this class: the common crawl, the Internet Archive, and the big Twitter data set. And all of the homeworks for all of these different sections right here are going to be using those different data sets at different points. So there's not going to be like 1 week that's dedicated to the common crawl. It's going to be, things are going to be slowly introduced as we tackle different things about SQL, and you'll be adding various features to your database that handles those different data sets. Good question. Any other questions so far? Okay, so last, other policies. So in this class, you should have gotten an email about login credentials to the Lambda server. Starting on Friday, we'll be going into detail about like how to use the Lambda server. If you've never used a Linux system before on the terminal, then I'll have some review material for you to reference for that. But everything in this class has to be completed on the Lambda server, and you're not allowed for any reason to use a different system. There's also this text editor called Vim that you'll be required to use in this class. It is a system specifically for working with text in the terminal. And at the very beginning of this class, you might be really frustrated with this Vim text editor because it's very different and very weird compared to other text editors. But once we're like sort of in the meat of this class, when you're have an army of 1,000 computers that you're controlling from your own personal laptop, you really will need Vim to be able to do the different tasks that you're going to have to do. And so other IDEs that you might have used previously or text editors that you might have used previously, not allowed in this class for any reason. If you are one of the sorts of people who prefers Emacs to Vim, I will allow you to use Emacs. I will just stare at you menacingly, and I won't think less of you, but I might make fun of you. Axel.
Yeah, I had a question with regards to the Linux stuff.
Sure.
I haven't used a Linux. I haven't used like a Linux machine on my Mac, and I was wondering if there was, in terms of for the extra credit, is there any walkthrough or something that you would suggest in terms of setting that up or using it?
I know, so Macs are a little bit harder to install Linux on than PCs. I know people do it, and I'm sure that there are good tutorials out there, but I don't know any off the top of my head.
Since Mac is, I mean, the Mac system is already kind of is more similar to Linux, and right, if I'm not mistaken, do people who, I know not many people who actually are in computer science perhaps use Macs, but would you suggest just like trying to go with that Linux route, or would you suggest just staying using the terminal and the basic stuff like that?
Yeah, so the question's basically, what is the advantages if you already have a Mac of installing Linux? And
yeah,
I'd say there's a lot more advantages for somebody who has a PC who uses Windows to install Linux. If you have a Mac, the main advantage is that by installing Linux, it's going to force you to think about a lot of things about your computer that you maybe haven't had to think about before. So you'll learn about something called partitioning your hard drive and managing different package repositories. And if you use a system like Debian, like it's 100% open source. And so that has both advantages and disadvantages to it. So I'd say for like a Mac, the advantages are really more cultural, that it would expose you to the culture of Linux and open source. Whereas for Windows, the advantages will be both cultural and technical that you'll get out of using Linux.
Okay, thank you.
Yeah, good question. So collaboration policy in this course, you're encouraged to discuss all the labs and projects, everything in this course except the exams with other students. We do have 2 TAs in this course through the QCL and some other systems. I'll introduce you to them later on. And if you collaborate with any other student or any human, including a TA or including anybody who is not me outside of class time, then you get a 2-day extension on all take-home assignments. So collaboration, highly encouraged in this class. And then accommodations, we'll see at different points in this course, I'll talk about accommodations and ways that I've made the course try to be accommodating for everybody, and also how to make just programming in general accommodating for everybody. But if you do have any additional accommodations that you would like, just feel free to let me know, and I'll definitely do my best to help you. I want to make sure that we click over here to the week 0 folder to see, just get an overview of what we're going to be covering on Friday in class. And again, every week in this class is going to just have a different folder appearing in the GitHub repository that will have all the material that you'll need for that week. And so this week 0, which is basically going to be just Friday's class, what we're going to be covering is a review of the Unix shell. These are the particular concepts that we'll be going over. Again, all things that we've, if you took CS46 with me, it'll be a review. If you did not take CS46 with me, some of it may or may not be review for you. And so I recommend trying to review this material a little bit before CS46, or sorry, before class on Friday. Down here under this pre-lecture work section, I have this video is something that I would like everybody to watch before Friday. And then there's some optional videos. And then this material right here is in particular for the people who did not take CS46 with me, or if you just don't feel comfortable with Git for whatever reason. This is some material to review that, which will help you review Git and the terminal. So complete that. It's okay if you don't have a full understanding by Friday, but looking at this before Friday will help you significantly during Friday's lecture. And then also I'd ask you, there's 4 cheat sheets right here that will also be good things to have handy throughout all of the lectures and while you're working on your assignments. So print these out and have them handy for our lecture on Friday. Any questions about what to do before Friday? Okay, maybe another good pre-lecture task for Friday that I don't have written here explicitly is that you all should have some login credentials to this Lambda server, and you should try to make sure that you're able to log in into the server and that you have access to it, that's all working. That way on Friday, you'll be able to follow along during lecture, and you'll also be able to actually start working on this week's lab and homework assignment. Yeah, the lecture on Friday, I think, will be a lot more engaging than this first one. We won't just be staring at text all day. We'll be actually diving into programming, working on the terminal, navigating computers, and doing some cool stuff. Let's see, Thomas, question?
Yeah, I don't know if this is like, if anyone else had this problem, so I can ask this question later. But when I was trying to log into the Lambda server with the instructions on the email, and I'm trying to change my password, it just says permission denied, please try again. And then I tried a few more times and it says public key password and kicks me out.
Anybody who's having problems with the Lambda server after class here, I'll be available to just go over, meet with everybody one-on-one to make sure that that we get that worked out for everybody.
Thank you.
There's a question in the chat about where will the recorded lectures be posted, and there'll be a GitHub issue that has a link to the lectures. And again, so this lab assignment down here for this first week is going to walk you through about a little bit more about using GitHub, getting connected to the issues, so that you, in particular, if you're watching this repository, you'll get an email about all of the announcements that I make. Question about, will assignments be posted to Gradescope? We will not be using Gradescope in this class. I personally don't like Gradescope because it is not as something actually used in industry. It's something that is sort of like a tool only for academia. I don't like things that are only for academia that students don't use after you graduate. And so everything will be done on GitHub using actual industry tools, actual continuous integration, actual, yeah, and the first labs and homework assignment will walk through how to do that. I don't want to keep us any longer. We're out of time. So this will be our official end of our first class session. It's good to sort of see you all on Zoom. Look forward to seeing you all in person and to seeing you again on Friday. But again, I'll be sticking around after class here if anybody has questions about anything else specific to the class things that we covered today, or the getting your account on the Lambda server to actually work.
Thanks, Mike.
You're welcome. Goodbye, everybody.
Thank you.
Mike.
Thank you.
Thank you.
Thank you.
Okay, let me stop our recording here, and then Zoom is slow.